Welcome back. McMullen here one more time. We're talking about interval notation, but this time we're going to be looking at specifically how interval notation can be used to describe the behavior of a polynomial function. In this case, we can see here we've got f of x is x cubed minus 2x, and we're using Desmos for this, so you can see the display here, the graph, and I've got the relative maximum and the relative minimum displayed along with their coordinates here. And we're just going to describe the intervals over which this function is increasing and decreasing. And so to do this, we're going to start by describing where it's decreasing. We're looking for the x values where it's decreasing. We can see here it's decreasing, excuse me for that. It's decreasing starting at x equals 0. And it decreases until x is equal to 1.3 repeating as a fraction. That's going to be 4/3. So these are our endpoints of where this is decreasing. And I want to make sure we understand that the maximum and the minimum are not points where the function is increasing or decreasing. So when we talk about the interval for where it's decreasing, we know that, so I'm just going to jot this down over here. Where it is decreasing, and we're going to say that it's decreasing from 0 to 4/3, and I'm not sure that, well, I'm not very happy with the functionality of Microsoft Paint here, but you get the idea. I hope you get the idea. 0 to 4/3 is the interval over which it's decreasing. And note here that we're using parentheses because, as I mentioned a moment ago, the maximum and the minimum points are not included in the interval over which the decreasing is happening. It's neither decreasing nor increasing at either of those points. So it's pretty straightforward to describe how it's decreasing. But what about where it's increasing? Talk about that. Well, it's actually increasing over two different distinct intervals. And one of them, it's increasing starting at negative infinity, right? Oh my goodness. Back to my, let's start starting at negative infinity. And then where does it stop increasing? Well, of course, it's increasing from negative infinity all the way until we get to that relative maximum at 0, 0. So we'll say that it stops increasing when x is equal to 0. There's our increasing interval. I'll go ahead and jot that down over here if I can get the tools working right. I don't know if I can. So it's increasing from negative, oops, well, of course, now I can't draw it. Well, I'm just going to draw it in with my pen. There we go, negative infinity to 0. It's a little sloppy compared to the font, but at least I can get the actual symbols here. Now, the next thing is we know that there's another interval over which this is increasing, right? It begins increasing again when x is 4/3. Of course, it doesn't increase at the point where x is 4/3. But it increases there, and then it continues doing so forever. And so it increases again from 4/3 to infinity. And because there's two different intervals over which the function is increasing, we can do that by describing the intervals separately. I can say 4/3 to infinity, like that, if I'm describing where it's increasing. Alternatively, if you are accustomed to using, if you've taken geometry, unions and intersections, because these have no overlap, but we want to describe the interval over which it's increasing with one statement, we can say that it's increasing from negative infinity to 0, as well as we're going to use the U for union, as well as from 4/3 to infinity. So that's a way to describe multiple different intervals over which increasing is occurring using the union in the interval notation. All right, I think that's about it for this time. Thanks so much.